lesson 10C on section 14.3. It's going to be applying solving matrix equations and applying matrices to systems of equations. So we're going to start by finding inverses. We're going to find inverses of 2 by 2 by hand. We're going to find inverses of 3 by 3 and larger with the calculator. We're going to solve matrix equations, and we're going to solve linear systems with matrices. So before we can actually find an inverse, let's define what an inverse is. The inverse of a square matrix, okay, so this only applies to a square matrix. And if I call it matrix A, it's denoted with A to that -1 right there. That's what tells me it's an inverse. And it's the matrix so that the product of A and A -1 is the identity matrix, which the identity matrix is for 2 by 2, 1, 0, 0, 1. If I talk about an identity for 3 by 3, that's going to be 1, 1, 1, 0, 0, 0, 1, 0, 0, 0, 1. So you can see I have ones down the diagonals and zeros everywhere else. If you think back, we had a homework problem where I had you multiply by that and it came out as the same thing. So the identity matrix that results will be the same size as matrix A, and that makes sense because a 2 by 2 multiplied by another 2 by 2 is still going to be 2 by 2. Now here I give you A and A inverse, and I'm going to show if I multiply A times A inverse, which will be 2, 5, 2, 4, multiplied by -2, 5 halves, 1, -1. As I run and dive, I get -4 plus 5, then I'm going to get 5 minus 5, -4 plus 4, and 5 minus 4, which gives me a lovely 1, 0, 0, 1. Now if I multiply them in the other order, if I have the inverse one first, again, you could test this out on the calculator as well, but since it's a 2 by 2, I'm just multiplying it out. -4 plus 5, then -10 plus 10, and then 2 minus 2, and 5 minus 4. So you get 1, 0, 0, 1. Boom. So when you multiply something and it's inverse, it's the only situation where switching the order of matrices, you'll get the same result. Because as we saw in the last lesson, matrix multiplication is not usually commutative. I can't usually switch the order I'm multiplying and get the same result, but I do this. And that result is always the identity matrix. So if it is invertible, so this is a really big if because not everything is going to be invertible. If it is invertible, our inverse is given by that monstrosity. So if I have A is here, B is here, C is here, and D is here, my A is now down in that corner, and my D is right there. So an A times D. Okay, so what's happening is these two flip, and these two on my other cross, B and C, change their opposites. And then I have this fraction in front of it. Okay? Now, the part here of if it is invertible, that's only going to happen so long as I don't have a denominator in that denominator be 0. AD minus BC cannot equal 0. And it can't equal 0 because friends don't let friends divide by 0. 1 over 0, that would be a big old no there, and we wouldn't want that, right? Because we don't want no. Okay, so find the inverse of the following matrices if it exists. First thing I want to do is test that number on the outside. I'll have -2 minus -6. So that was from finding that and that. -2 times 1 is -2. -6 times 1 is -6. And then it does have a subtraction between them. Okay, so that's going to be plus plus, and so I'll have a 1/4 on the outside. That's going to work. So I'll keep going from there. 1, so this first diagonal are swapping spots, 1 and -2. The other diagonal are changing signs. So here is my 1. So that one has it with the scalar multiplication on the outside. I could multiply it in and write 1/4, -1/4, -1/2 in that spot, and 3/2 there. I just simplified the fractions. Either one is fine. You can use the calculator to do the multiplications for you as well. So let's check our 1/24 minus 45. That one's going to work too. So these two swap, these two change signs. And then on the outside, I'm going to have, why am I having a brain fart? 1 over -21. Or 2/7. So you could have either one of those. All right, so again, I'm going to start by finding my different products. So I'm going to have 0 minus 0. I have a 1 over 0. This one does not have an inverse. So you're going to write no inverse or not invertible. All right, next one. 1 over 18 minus 18. No inverse again. Okay. All right, we can also use the calculator to find inverses. This is really important for ones that are larger than 2 by 2s. So but it does work for a 2 by 2 as well. So for this 3 by 3, I'm going to go second x to the -1. That gives us the matrix menu. I'm going to go over and edit. I have my 3 by 3. I should have this one there. Let's. Oh, why did it just? Oh, it moved the page. Sorry about that. So I have it typed in 721 0 3 -1 -3 4 -2. Perfect. So second mode to quit out of that. Now we're going to go back to that matrix menu, second x to the -1. I'm going to select A because that's where I typed that matrix in, and I'm going to hit that x to the -1. So my inverse here is -2, 8, -5, 3, -11, 7, 9, -34, 21. And just to confirm, if I take that matrix and I multiply by, oh, that wasn't matrix, try again, by A, it comes out as the identity. There's one slight little rounding error here with that 1/2 times 10 to the -12, but that's just a rounding error on the calculator. Matrix equations are equations involving matrices. So I have this equation here, 4x plus a matrix of 1, 2 is equal to another matrix. Now, if I had instead an equation that was 4x plus 1 is equal to 9, the first thing you do is subtract the 1, and then you divide by 4, right? I'm going to do something very similar here. I'm going to subtract this 1, 2 matrix. I get 4x is equal to 8, -12. And when I subtract, I'm doing that fine because I have the same dimensions and I just subtract the corresponding pieces. Now I'm going to multiply by 1/4 because we're not allowed to really divide matrices. We never divide matrices. We always multiply by something. So to get rid of that scalar, I'm going to multiply by the scalar of 1/4. So I get 2, -3, final answer. All right, so the one next to it, I'm going to do the same kind of thing. I'm going to subtract. And you can think about this as no different than -1/2 x plus 3 is equal to -12. And I'm working from there. Okay, -1/2 x is going to be -15. -4 minus 4 is -8. 5 minus 6 is -1. 10 minus 5 is 5. Then to get rid of this -1/2, I'm going to instead multiply by -2 as my scalar. That'll give me 30, 16, 2, and -10. Final answer. All right, so now here, this one's different. Notice I'm not adding them together, I'm multiplying them together. And the way we can undo a matrix multiplication is by multiplying by its inverse, which is why we started with inverses. So I'm going to first, if this is A, okay, I'm going to find A inverse. Again, I could use the calculator to do this as well, if I'd like. And so I'm going to have 1 over 4 times 2 is 8 minus 14. Swap spots, change the sign. So, and I could multiply that in if I want, but I think I'm just going to leave it on the outside. So, this is my inverse. And what I'm going to do is I'm going to multiply it by it on the left on both of these. 2274. Okay. Here's the one that was there to start. Now see how my blue matrix that I'm multiplying in is on the left here? I'm going to have it on the left here as well. And that's really an important step because the matrix multiplication, if I had it in the other order, it wouldn't be defined. So it's an important thing. Now if I multiply these out, that's going to come out as the identity because they're inverses. Now here, I'm going to still do the 1/6. I'm just going to multiply here. 2 times negative 6 is negative 12. 2 times positive 12 is 24. Then negative 42 plus 48. So if this is just a fancy way of writing 1, I'm just going to write just x now. Negative 12 plus 24 is 12. Negative 42 plus 48 is, oops, sorry about that, 6. And I multiply my 1/6 then. X is 2, 1. Boom. So if I was going to use my calculator to help me, go into second, x negative 1. I get my 2 by 2. And this is my original one, 4, negative 2, negative 7, and 2. And then I'm going to do a 2 by 1 here. Negative 6 and positive 12. So first thing I'm doing is I'm taking my matrix A, I'm finding its inverse. Okay, then I'm going to multiply that by B. Negative. Oh, because I'm a sign error. I apologize. That should be negative. Negative, 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 negative. There we go. See? Good thing we checked. So, one of the things we said we would do is use this to solve systems of equations. So, what I'm going to do is take this system of equations, which you should recognize from Algebra 1. So, if I was going to do it from an Algebra 1 approach, I'm just going to do it over the side. You'd be like, oh, well, those two y's, they are like set up perfectly for elimination. You cancel the two y's, say 4x is equal to 12 and x is equal to 3. Then well, 3 minus 2y is 7. Subtract 3. Negative 2y is 4, so y is negative 2. Boom, boom, right? Okay, good. I'm glad we remember Algebra 1. Now we're going to use matrices. I'm going to solve this exact same problem using matrices this time. And part of the reason we have more than one way to solve it is because while this was really easy for 2 variables, not every problem is going to be easy for 2 variables. And as we start to have 3 or 4 or 5 variables, it can get very challenging. And this provides a way to use calculators or other software to help us solve them. So x minus the coefficients, I have a 1 here, I have a negative 2, I have a 3, and I have a 2. So that was my coefficients here. 1, the negative on that, 2, and 3. My variables are x and y, and my other side is 7 and 5. Okay, so really what I'm having is 1 times xy gives me 7, 5. And that really is a true statement, because as I run and I dive, I'm having x minus 2y, and then on the other side is 7. Okay, and then when I run and dive, I'm going to have 3x plus 2y equals 5 on the other side. Okay, so you don't need to actually multiply it out. I just want you to see where it's coming from. Now this matrix equation is no different than the matrix equation 1, negative 2, 3, 2, some mystery x. Okay, and this is just saying, or since I called it b, let's call it b to match this b. All right, so we're solving for b. We want to find the inverse of this first one. So the inverse of a is going to be 1 over 2 minus negative 6. Flip these, change the signs. 1/8 to 2, negative 3, 1. All right, so I'm going to have to multiply by that on the left on both of them. I could multiply the 1/8 in if I wanted, but I'm not going to, because I don't want to deal with fractions if I can avoid it, especially because I'm doing it by hand. If I was going to use my calculator, then I don't really care about the fractions. So the calculator's going to do it for me. All right, so I'm going to have 14 plus 10, and then negative 21 plus 5. And so 1/8, 24, and negative 16. And when I multiply that in, I get 3 and negative 2. That's what b is equal to. Which corresponds that that top piece was x, my bottom piece was my y, negative 2. Same answer. Yes, it was more work for this particular problem because it was a very straightforward system. But as you get to other things, it might be less work. And isn't it wonderful that we can solve this problem in a different way that we hadn't seen before? All right, so take a moment, pause the video, and try this problem, please. Okay, so I'm going to write my matrix 7, 2, negative 1, positive 2 times some mystery b. You can use any letter, capital letter that you'd like there. Okay, this time I'm going to use my calculator to help me out. So I'm going to go second x negative 1. I'm going to edit the pieces I had in here. So I had 7, and then 2, negative 1, and then another positive 2. And then on this one, 2 by 1, negative 19, and positive 20. All right, so I'm going to take matrix A, find its inverse, and then I'm going to multiply that by matrix B. Boom. So, oh, sorry, B is negative 5, 8. So that's telling me x is negative 5, y is positive 8. Boom, with the calculator, so easy. We can also do it with larger systems, which is, again, one of the real benefits of this type is that I can do this on larger systems as well. So I'm just going to have more pieces here. Since I have a larger one, I'm only able to, well, I didn't show you how to find the inverse of a 3 by 3 by hand. Yes, it is possible. No, we're not doing it in this course. It's a cool thing, just not what we're doing, not one of our objectives. Okay, so there's my matrix equation. So I'm going to go back to my calculator. I'm going to edit this to be a 3 by 3 now. Well, just be very careful as you're typing this in, because you don't want to make a mistake with typing. And we're just going. When I proofread, a lot of times I proofread in another direction, so I'm going to go up, down, up, okay. And then we want this to be a 3 by 1. We'll have 2, positive 19, and positive 20. So I'm going to find the inverse of A. You can math frac it to see fractions if you wanted. And if you see the dot, 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 you can scroll over to see the rest of it. And then we're going to multiply that by matrix B. And math frac it again. That doesn't seem right. Let's double check. Matrix A, negative. And so I'm just proofreading as I had typed in to make sure I didn't make any sign errors. And B, oh, there it is. It's negative 20. See? Told you. I had even said it was so important to. So find the inverse of A. I apologize. And then we're going to multiply by the correct B. There we go. And so we end up with that B is the matrix of 2, negative 3, 3. And that's telling me that X is 2, Y is negative 3, and Z is positive 3. If you haven't seen a 3-variable system before, this is really talking about 3, instead of lines intersecting, where 3 planes would intersect. And these 3 planes intersect at the point 2, negative 3, positive 3 in space. All right, so one more. Why don't you pause the video and try this one? All right, and so we have negative 1, negative 5, 1, negative 5, positive 5. Oh, see, negative 5 there. Positive 5, good. 2, 5, negative 3 times some variable 1, 17, 5, and negative 10. Okay. So we've got negative 1, negative 5, positive 1, negative 5, negative 5, 2, 5, 3. Okay. And 17, 5, and negative 10. Okay. So I'm going to have matrix A, find its inverse, multiply that by matrix B. So we end up with X equal to negative 1, Y is negative 4, Z is negative 4. So really important here, notice the order I'm typing things in matters. I can't do B multiplied by matrix A, the inverse of A, because watch, it's just going to give me an error because the dimensions don't match. And that's because I'm doing a 3 by 3 multiplied by a 3 by 1. That's good. 3 by 1 times a 3 by 3, that will not work. So it's really important that we do things in the right order. And that concludes our lesson on matrix systems and equations and inverses of matrices. Thank you.